Right, so today I'm going to talk about image performance. It's a broad topic, and I've been reliably informed that I'll be rugby tackled to the ground if I go over 30 minutes, so I'm going to talk really fast and hope we get there. So what do I mean by performance? In the context of images, it usually refers to image quality, file size, memory usage, loading time, drawing time, etc. Those are the kind of performance metrics we care about. Image performance is always a compromise. By default, Apple optimizes for image quality and memory usage and loading time, not so much for drawing speed and not so much for size on disk. As engineers, you're probably familiar with this triangle, the good, fast, cheap, pick two. This is the face of compromise. In the context of images, good would mean high resolution, high quality. Fast is it loads and draws quickly. Cheap means it doesn't consume too many system resources. So we need to make the right trade-offs in order to avoid compromising the user experience, balancing the different variables to try and get the best result. I'm going to look at file size versus image quality initially. So there's kind of three variables that we can play with when it comes to adjusting our file size versus image quality. We have resolution. Now, as an iOS developer, that's kind of dictated to you. So, if it's a Retina device, it's going to be one resolution. If it's non-Retina, it's another. You don't have a lot of control over it. So we can kind of forget about that for now. Compression settings. So depending on which image format you're using, you may have, settings that you can change that will affect the image quality or the file size. Again, generally, we're going to just try and produce the best looking images we can and then compress them as much as we can get away with. So there's not really a lot of discussion there. It's just going to be the highest compression you can get away with and still have a decent looking image. So that leaves file format. Now, the file format, how do we select the right file format basically for our images? If you read the documentation, they'll say just use PNG for everything, which is a simple answer. PNG is Apple's format of choice. It's also now the only format that's supported by XE asset catalogs. And it's kind of the only thing that you'll see suggested by Apple. I think it's important to understand that PNG doesn't really mean what you think it means. So when Apple says PNG, they typically mean CGBI. CGBI it's not really an official format. It's so named because of an additional header that Apple add to PNG images when they optimize them. But basically, any PNGs that you include in your project get reconverted into CGBI images. And Apple calls this feature image or PNG optimization. But what do they mean by optimization? Well, what they're really doing is they're swapping the byte order of the colors, and they're pre-multiplying the alpha. And they convert any kind of weird PNG formats like 8-bit paletted back into 32-bit. The reason they do that is because it improves the decoding performance. They're not doing it to reduce the file size. And in fact, some of the changes they make to the files may actually make them larger. It is possible to disable this optimization. I wouldn't necessarily recommend it. So Apple's advice to use PNGs is kind of predicated on the assumption that you're using their CGBI images, not real PNGs, and the performance is actually quite different. It just doesn't really apply if you're not using CGBI images. So PNGs that you download, they're not the same kind of thing. So there are some other options when it comes to image formats. I've listed kind of all of the ones I could think of, but most of them aren't very interesting because they're generally worse in every way, or worse in most ways, than the standard image formats that you're going to use, which are these. Jpeg, you should hopefully all be familiar with. It's lossy compression, so it tends to make much smaller files than PNG. It's ideal for photographs, really, where you're not going to notice the kind of compression artifacts. A format that you may not be so familiar with is Jpeg 2000, which since iOS 5 has been natively supported on iOS, but hardly anybody knows about it. It's basically just like Jpeg, but it supports alpha, which is kind of the missing piece of Jpeg. GIFs are kind of popular for sort of funny videos and things. They're not natively supported on iOS. You can use a library to support them, but I'm not really going to talk about them. They're kind of a novelty format. And PVRTC is quite interesting, but I'm going to cover that later. So let's look at the size that different formats produce for a given image. So I've got some a selection of potential iOS images here. Starting from the left, it's kind of like most optimal for PNG, and then to the right is least optimal. So these images are actually all 1024 by 1024. They look smaller because I'm displaying them smaller. On the left, I've got line art with a transparent background, so the classic PNG best case scenario. As you can see, it compresses very well. It's a very small file size. The CGBI makes it a little bit smaller, but not significantly. And JPF, which is JPEG 2000, is actually larger, so there'd be no benefit to using that there. Slightly worse case, you've got a gradient background. You're going to see a lot of these on iOS 7 apps. It's kind of like the way that you add color now. These compress pretty horribly as PNGs. In practice, you probably wouldn't have a full background image. You'd maybe use a slice and tile it, so you'd get better compression that way. But a full screen gradient image compressed as a PNG is going to be pretty large as a file. And you can see that JPEG and JPF make it much smaller. And then you have the sort of PNG sort of anti-case, which is a photograph. This is a picture of my daughter. So the PNG file here is huge. It's over a megabyte. And the JPEG file is pretty small. It's 100K. So in that situation, you really want to be using a JPEG. And then here's the kind of worst case scenario, the one you can't really do anything about, which is a photograph with a transparent background, so with an alpha component. You can't use JPEG because it doesn't support alpha. PNG is really horrible, makes a massive file. JPF is quite good for this, so it makes a very nice small file, but it still supports the alpha channel. So overall file size tips, use JPEGs for photographs, backgrounds, PNG for UI elements, kind of small buttons, things. If you're generating these images yourself, if you're using Photoshop, always use the Save for Web option. It's kind of a pro tip there. It makes much, much smaller files than if you just save. Even if you take a PNG image you've opened in Photoshop and save over it directly, it'll make it much larger if you don't use Save for Web. There's a tool called Png Crush. It's a command line tool you can use to strip out unnecessary data from your PNG images. But if you're going to sort of hyper-optimize your images and turn them into 8-bit paletted or whatever, it's pointless if you're not going to turn off Apple's optimization, because that will basically just put all the data you've stripped out back in again. And kind of more of a philosophical point here, but I feel that image optimization is really an engineering problem. I think a lot of people treat it as a creative design problem. You let the designer give you a folder full of images to put in the app and you don't really think about it. Don't do that. In my general experience, designers are not concerned about the size of the files they're giving you, only the quality. So you can probably make them a lot smaller and significantly reduce the size of your app without any loss of quality if you just apply some of these techniques. OK, so let's move on to memory usage, as opposed to size on disk, which is quite different. So when we load an image, it's a two-stage process. Step one, the data is loaded into memory. And at this point, it consumes the same amount of RAM as it does on disk. It's basically just a blob of data you've loaded. So there's no difference at that point. Step two, the image is decoded. And this has to be done before the actual image is actually drawn. And at this point, the RAM that the image consumes is always the same. So for a given image size, regardless of what format, the amount of RAM consumed is always the width times the height times 4 bytes, 32 bits. There is an exception to that. I'll come back to it. But generally speaking, that's the case. And that makes for some serious memory consumption. So I've got some examples here. The images in this app, which are 1024 by 1024, they're 4 megabytes when they're decoded. An iPhone 5 full-screen image, that's 2.8 megabytes. A Retina iPad screen is 12 megabytes. And a raw iPhone 5S photo, when it's decoded in memory, is 30 megabytes. So you don't want to have a lot of those decoded at once. So let's look at the performance of loading images as opposed to size in memory. And again, another philosophical point here. When you're measuring performance, or when you're looking at performance, you really need to measure it rather than kind of rely on past experience, rules of thumb that you already know. Every device is different. Every new OS version can potentially change the performance profile of an existing device. And so really, the only way that you can be sure that you're doing the right thing is to actually measure how long it's taking to load and draw your images. And you may have noticed that this isn't an ordinary Keynote presentation. This is actually an app. You're looking at a UI scroll view here. And the reason I've done that is so that I can show you a live demo of loading images with actual performance measurements. This is an iPad 3, which is kind of like the worst possible hardware. So I always work on the principle that if it works on here, it'll work on anything. So let's look at loading time. When iOS loads an image, it defers loading and decoding until the image is drawn. So when you init an image, it's not loading it, it's not loading the data, and it's not decoding it. It's actually, typically it will be loading a memory mapped data file. So everything stays on disk until it's ready to be drawn. There's no direct API available for actually decoding the image, but you can force it to decode by drawing it. So if you draw it into a CG context, that will force the image to decode. Sorry, getting a bit of dry mouth there. So here's some code to do that decoding. Don't worry about the code. I'm going to shoot through it quite quickly, but the presentation is available to download later. So here's some performance measurements. The first thing you'll notice here, so the blue part of the bar is loading time, so that's init time, if you like. And the green part is what happens the first time we try and draw the image into a CG context. So nothing too surprising from PNG and the CGBI, which is the optimized PNG. Jpeg, as you can see, is actually a little bit quicker here. This is the gradient image. If I use the star image, oh, you don't have the JPEG there. But the key thing to notice here is that JPF, which is the JPEG 2000 format, although it's natively supported, has really horrible decompression. It's really, really slow to decompress these images, much, much worse than JPEG or PNG. So if you really need the space, you probably have no choice but to use JPEG 2000, but from a performance standpoint, you should try and avoid it. Sorry, the other thing to note with this is the decoding time totally dwarfs the loading time. I mean, there's no comparison at all. Loading is almost totally irrelevant. It's all about the decoding. So how do you load an image, and you know, what difference the different loading methods make? The typical way you would load an image is to use the image named method. At least that's how you would load a bundled, resource image. And this is kind of the preferred way to do that. It only works for embedded images. And it defers loading and decoding, as I was saying before. But crucially, it caches images once they're loaded. So the second time they're drawn will be better performance. Image with contents of file, or init with contents of file, or init with URL, they're all the same. Again, similar, works for locally stored files, but it doesn't cache the image. So that's the main difference from image named. Image with data, so this is kind of splitting image with contents and file into two methods. The only real difference with this is that it doesn't defer loading. So when you create the data, it's going to load it immediately, unless you explicitly create a memory map data file. So you can kind of force the loading step, but as we've said, the loading step is pretty fast anyway. It doesn't make a huge difference. And then there's the more complex option is to use image I/O, which is a lot more code, as you can see. The benefit is that it allows us more control over decoding, which I'm going to cover in a bit. So loading performance. This is basically the performance of those 4 different ways of loading. And as you can see, they're all pretty similar. It doesn't make a huge amount of difference. If we switch to CGBI, again, not a huge amount of difference. A different image, yeah, there's not much to choose between them. One thing you possibly will notice, I might have to reload it a few times to really show the effect, but yeah, you can sometimes see that the with data method takes a little bit longer in the loading time because it's not got the deferred loading, but I think it's within the tolerances of the measuring system, so it's not always going to show up. To effectively optimize images, we kind of need to understand the whole loading, drawing process. So the process is really that we initially load the image when we init it. Then we have to decompress and decode the image and then draw it. And we'll probably repeat these steps. The overall performance depends on all 3 of them. So if I include the second draw time, so basically the next draw after the first draw when the image is decoded, we can see that image named is dramatically faster, and that's because of the caching. So what's going on here is that effectively there's no difference between the first and second time we draw an image, because as soon as it's drawn the image and doesn't need the decoded version anymore, it throws it away. Which means that the next time you draw the image, it has to be decoded again, and so on. So you're taking a performance hit from that decoding every single time, but the reason it's doing it is to save that potentially 30 megs of RAM or whatever from the decoded image, which makes a lot of sense as a default. So up until now, we've been forcing our images to decode by drawing them into a core graphics context. If we want to avoid that hit from the decoding each time, we can basically keep the image that we've drawn and throw away the original. And so because we've now only got the decompressed image data, iOS isn't capable of sort of throwing that away and going back to the encoded version. So that essentially means that Now, when we're drawing using the redrawn image, the performance is quite similar to image named. The second draw is much faster than the first. We can also decode our image using image.io, which I alluded to earlier. So there's a couple of options we can add when we're creating an image with image.io. Image source should cache. It's been around for quite a long time, since iOS 4. What that basically means is that once it's decoded the image at a particular resolution, it should keep that decoded version. So effectively, that's replicating what image named does in terms of caching our images. So that's pretty useful. But it doesn't help for the first time we draw the image. The first time we draw the image, it's still going to do that decoding. It doesn't decode it in advance. There is a new property that was added in iOS 7, which is image source should cache immediately. And what that does is it actually decodes the image when you init it. So it does the loading and decoding immediately. And if we look at what effect that has, you can immediately see here that when we're using cache immediately, I need to stop saying immediately, in the loading step, which is the init step, suddenly that's much larger because all of the decoding is happening at that point. And then our two draws are essentially taking the same amount of time. So this sounds great because if we've got a situation where we need to draw our images really quickly, theoretically at least, we just decode them on a background thread and then we're not going to have any hit when we're drawing the images. That's the theory anyway, right? So here's a image carousel. I don't know what the performance is like. Hopefully, it should look bad because that's the point. So this is loading using image named. If I switch to using redrawn images, so ones where I've pre-drawn them on a background thread before I try and display them, you should have nice, smooth performance. Now, you are going to have gaps because it's loading asynchronously, but critically, it's not blocking user interaction at all. The thread, main thread isn't stuttering. And you can do things to improve the actual loading performance, but as long as the main thread isn't stuttering, you're doing well. So what happens if we use image source should cache immediately, which should do the same thing? Well, here our main thread is still stuttering. It's, unfortunately, even though we're decoding the images, we're knitting them on a background thread, image source should cache immediately still blocks the main thread. I don't know why. I don't know if it's a bug or some kind of strange design decision, but it basically makes it useless, or at least useless for the purpose for which I would want to use it. There is another option, however. Quite often when you're loading images, incidentally, these are iPhone 5 camera photos, so these are huge images. We're displaying them much smaller than the actual image size. And that's the point, really. So when you're displaying images, you're often displaying them smaller than the actual image size, particularly if these are user photos. You're going to be loading them from the camera roll, but you probably want to show small thumbnails or a carousel of smaller images. So how do you get those thumbnails? Well, you can use core graphics, and basically exactly the same technique we were doing, but instead of drawing the image at full size, we just draw it into a smaller rectangle. And then that's our decoded image. And there's actually two advantages to that. One is that, obviously, it's using up less memory because the decoded image is smaller. But also, if it's a Jpeg image, iOS is smart enough to decode less of the data. So Jpegs are frequency-based, and it won't decode the high-frequency data because it doesn't need it. So decoding will actually be faster, as well as drawing, and then using less RAM. So that's the way that we can decode it using core graphics to generate a thumbnail. We can also generate thumbnails with image.io. Slightly different method, but essentially the same idea. And interestingly, when you generate thumbnails with image.io, if we look at the performance chart here, that actually happens at init time. It doesn't happen at first draw. So our thumbnail is being generated immediately when we initialize an image using image.io and specify a thumbnail size. And although it seems to be taking a little longer here, I wouldn't read too much into that, this is actually doing what we would hope that Decode immediately would do, which is that it's decoding our image at a specific size on a background thread, or it will work on a background thread rather than blocking the main thread. And incidentally, this is a good demonstration of the difference between PNG and CGBI in terms of performance, because if I decode a CGBI image instead, you see that image.io's thumbnail generation is actually faster than any other way of doing it. Whereas for ordinary PNG images, like the ones that are actually conforming to the standard, it's worse. For JPEGs, it's still faster. So basically, for anything except regular PNGs, if you need a small version, if you need a thumbnail, you're better off generating it using image.io rather than drawing it yourself. And if we try our carousel again, so if I'm resizing using image.io, it's perfectly smooth. I mean, again, it still takes a little while, but it's not blocking the main thread at all. And this is downscaling from 3264 to 1400 pixels in real time as I'm going. So, CPU versus GPU. So, both decoding and drawing can actually be handled by the GPU rather than the CPU on iOS. And that is actually the default behavior, really, because when you assign freshly initted UI image to layer.contents or imageview.image, it will actually decode it on the GPU and then draw it using the GPU as well, which is faster than anything you can do with core graphics or image I/O. The only problem is that it blocks the main thread. So if it's not fast enough, you're going to get stuttering. So really, you kind of want to use that route. That is the default route. That's why Apple made it that way for almost everything. But when you're in a situation where you have an image carousel and you're trying to load those images within a 60th of a second, that generally won't work, and that's the only reason why you wouldn't want to use it. So to decode on the GPU, assign to layer contents. To decode on the CPU, use core graphics or image I/O. So I think I've kind of already covered this one. So there's some disadvantages to decoding on the GPU. Apart from blocking the main thread, you can't decode images greater than GL max texture size, which varies per device, but it's usually either 4096 or 2048 by 2048. It doesn't support that partial JPEG decoding thing I was talking about before, so it always has to decode the whole image, even if you're only going to draw it at a tiny size. But it's almost always faster than using the CPU in other situations. Drawing on the CPU is almost, drawing and decoding on the CPU is almost always slower, but it can be done safely in the background and concurrently. So when I say in the background, I mean if your app is not the foreground app, if it's gone into the background, you can still keep decoding stuff using core graphics, but you can't with the GPU. And it supports any image size or format, and it has that JPEG decoding system. So decoding tips generally. You probably want to load and decode images on a background thread prior to display to avoid frame rate drops, if you can, if it's necessary. You should try and redraw your images at the correct size for display. It's not always possible, because you don't always produce the images, but if you're going to bundle images with your app, bundle them at the size you actually want them to save excess decoding and drawing time. I would say don't use image source should cache immediately unless somebody can figure out a different use for it than this, because it just doesn't really help. But CG image source create thumbnail at index actually works pretty well as a way of pre-decoding your images, with the added bonus that you can also scale them to whatever size you want. So a thumbnail doesn't have to be any smaller than the original image. You can have a thumbnail that's the original image size, but it comes out decoded. Drawing tips, it's almost always faster to use the GPU. You definitely want to draw images using layer contents or imageview.image, not using drawrect. The only exception to that is if you have a situation with overdraw, where you have multiple overlapping translucent images. Potentially that's quite expensive for the GPU to compose. If you can draw those offline into one image, that'll be quicker to display. And never try and draw images that are larger than GL max texture size. So if you've got an image you've loaded that's like 5,000 pixels wide, do not stick that straight in an image view, because OpenGL can't display it directly, and Core Animation will have to do something horrible to make that displayable, and it'll probably block the main thread while it's doing it. Caching. So we've established that the loading and drawing process can be split into these 3 steps. We don't want to do those 3 steps every single time that we draw an image. Basically, by using caching, we can skip the loading and decoding step after the first time. If you use image named, it does that automatically, but you can't use that for images that you're loading at runtime. Disk caching, obviously, if you're downloading images, you want to save them to disk rather than downloading them every time you display them. For images that you're loading not using image named, you can cache them in memory using NSCache, which is a least recently used cache, so it will evict the image you accessed least recently, which is usually what you want. There's a lot of potential problems around using NSCache, but it's a good, simple first solution. So to demonstrate the effect of NSCache, I've got my carousel again, and as I'm spinning it, you're seeing that the images are loading in. But once the cache is full, it's perfectly smooth. There's no popping in anymore because the decoded images have been stored in memory. Extreme measures. So these are extreme in the sense that they're probably likely to get WTFs from your fellow programmers if you don't warn them that you're going to do this. They're extreme in the sense that these represent typically optimization, extreme optimization of a particular principle, maybe at the expense of something else. The first extreme measure I'm going to look at is using uncompressed images, which is basically saving raw image data to disk to eliminate decoding time. So if you actually store your images in 32-bit BGRA format, which is the format that images are used in memory, you can skip the decoding step altogether. You can get the raw BGRA pixel data from an image using this method, basically just drawing it into a context that you control the backing data for. And you can load it again using the inverse method. You have to supply the size and scale because you're not storing any kind of headers along with this data. Although you could if you wanted to. And let's if you look at the performance at this. So the BGRA image, you can see it's 4 megabytes on disk. So this is a massive image, but it actually loads much quicker than any of the other formats. The loading step is a little bit longer, or quite a lot longer, but there's no decoding time at all. So the first draw and second draw are exactly the same length. So overall, it's much more performant. This is actually the technique used by the path fast image cache that you may have come across. It combines that with memory mapping so that it's not necessarily having to keep all of that decoded data in memory at once. But it's basically what it's doing is just saving raw images. So you download them, saves them as raw, loads them as raw. It's all nice and quick. Another option, so we talked before about the limitations of JPEG 2000. So JPEG 2000 is really horrible performance when you're loading it. Nice small files, really horrible performance. But there is an alternative, which is to use hybrid images. This is a term I invented, so it's probably not very Googleable. There may be a better term for it. But basically, I see hybrid images as being images that are made from 2 separate files that you've combined at runtime. So you have one file for the color portion of your image, and a separate file for the mask. Typically, I would use a JPEG for the color portion and a PNG for the mask. And the effect that this has, you can create an image like this using this code. There are other ways of doing it, but this code will actually decode it and give you back a decoded image, so you're skipping that step, or you're doing that step, rather. If we sort of compare the file size of a hybrid image to the other options here, so I've got PNG, CGBI, JPF with horrible performance, raw BGRA data with great performance, and hybrid is somewhere in the middle. But its size is only 200K, so it's the smallest apart from JPEG 2000, but with pretty much the same performance as a regular PNG. So it's quite a nice way of doing things. Again, if you don't explain to your fellow coders why you've done this, they're going to think it's a bit weird that you've got two image files for everything. The final extreme measure I'm going to look at is using Opengl texture formats. So I said before that once images are decoded, regardless of what format they were, they're all going to end up the same size. Width times height times 4 bytes, right? That's not strictly true. So iOS's pipeline only supports those kind of images, but Opengl actually supports a wide range of in-memory formats for images, and many of them are much smaller. So these are some of the internal names for the Opengl image formats you can use. You can have 4444, so that's 4 bits per component, with a total of 16 bits per pixel rather than 32 bits. You can have 8-bit monochrome images, which you can't normally do. Even if you save your PNG as 8-bit monochrome, it's going to load as 32-bit, but not if you use Opengl. And there's also some really interesting formats which are compressed in-memory formats. So these are compressed, but they don't require any decoding. These can actually be displayed directly by the graphics chip without decompressing them, which is pretty amazing. And with these formats, you can get as little as 2 bits per pixel, even though it's still 32-bit color. So the advantages of using PVRTC, which is the name of this format, and it is a standard format. You can get standard tools that will create these images and save them, and you can bundle them in your app. The advantages are kind of obvious. So they consume less memory when they're decoded than the other formats. And the data on disk exactly matches the data in memory, so there's no decoding time. The cons, well, they're bigger on disk than PNG, because then even the compressed formats are not as highly compressed as PNG. Although you can gzip them and still have pretty good performance. They can't be drawn using your ordinary UIKit code. This is probably the killer. You need to make an Opengl pipeline for displaying your images. Go to David if you need tips on that. They're expensive to encode, so they're cheap to decode. Well, they don't have to be decoded at all. But to actually encode these images can take like a minute per file. It's incredibly slow. It's an asymmetric algorithm. And the images also have to be square with power of 2 dimensions, which can be quite restrictive. But if you look at the results, so this image just loaded as I was swiping. This is actually a 4096 by 4096 image. Huge, high quality, transparent background. This would normally be 64 megabytes, this image. It's actually only 4 megabytes on disk or in memory. Massive difference. And as you can see, this is interacting quite nicely with UIKit components, even though it's an Opengl view. It's a pretty useful tool if you need it. So conclusions. Select the appropriate image format for your image type. Don't just always use PNG because the docs say to do so. Image size, loading time, and drawing performance are all interconnected. So the choices you make about how you load your image can affect everything right down the line to when you're drawing it later. Try and split the work intelligently between GPU and CPU. GPU is always faster, but if you're flooding the GPU with lots of requests, you're still going to be blocking user experience. And I would say don't use these sort of exotic formats that I've suggested unless you really have to, but it's worth knowing that they exist, because when you need them, they're a real lifesaver. Yeah, that's pretty much everything I have to say.